everyone. My name is Taylor McCampbell. I'm an undergraduate here at the University of Wyoming, and I'm joined here with Rafer Cooley, who's a PhD student here at the University of Wyoming, and we've been working on malware analysis at scale with Elasticsearch during the summer of 2021. Because of the sheer amount of malware and the amount of data that people are producing when they generate malware samples, we have big data problems, and so we need to generate big data solutions. So we're working with a ton of data. We need to be able to access it efficiently and effectively, and we need to be able to get what we want. So we need to generate big data solutions. Also, search engines have been developed to efficiently search through large streams of information. So we want to be able to apply this to malware, and we want to be able to get what we want and what we need from having a large test corpora. So that's the background of the project. Moving on to the problem statement.
When we started this research this summer, we defined a couple of problems that we wanted to try to solve during this research project. We wanted to know and understand how we could store and analyze such a large amount of information in an efficient way. And we also wanted to know how can we structure the different indicators that we generate or that we get from these threat feeds, such that the structure of these indicators can be exploited to efficiently store and search through that information. And then finally, as our stretch problem, as our overarching research problem, we wanted to know how could we develop indicators that work efficiently at scale, and what sort of features are necessary in order for those indicators to work at scale.
So the methods we used to complete these goals were Elasticsearch, which is a search optimized database. So when we're working with big data, we need a big data solution. So Elasticsearch allows us to search effectively and efficiently, and allows us to interact with and modify and retrieve data in an efficient manner. So we chose Elasticsearch for that database, which is what the 27 terabytes of malware that we're talking about, that's where that's stored. That's where all its characteristics and all the information we have is stored there. One of the ways we gather this information was using VirusTotal, which VirusTotal generates reports and runs malware samples through sandboxes and can give us a lot of information through their API or through just their general reports on their website, given a specific hash for a sample. So we use those VirusTotal reports to gather information on these samples. And then we also need custom comparisons to be able to analyze the malware. So we use a graph database for this so that we can have nodes representing different malware samples, and then we can draw comparisons that represent our locality sensitive hashes, or SSDeep and TLSH, which are the dynamic indicators that we chose to use. And that's all stored in Neo4j. And we also, to kind of rope it all together, there's a Python-based CLI program that will allow you to basically complete the whole workflow that we're looking for when generating this program. So a traditional workflow for the program would be like this. We would gather a malware sample that we're interested in, and we would store it in Elasticsearch. And then we would do comparisons against other interesting malware samples that we wanted to compare this new sample to. And so we would create nodes in Neo4j, and then we would use our locality sensitive hashes, or SSDeep and TLSH, to compare them. And when we would create relationships between nodes in Neo4j, which represent malware samples, that would represent a certain similarity between the samples. And then we would do all of that from our Python-based CLI program in the command line.
And by the end of the summer, this software and this framework that we have developed has successfully indexed over 5 million individual reports for the different samples of malware that we have. We have developed the locality sensitive hashes for all of these samples, such as the SSDeep and TLSH hashes for all of these samples, and they have been indexed into Neo4j so that we can perform our comparison analysis between these different samples. We also have the Elasticsearch fully up and running and is able to give us meaningful information about our samples from the VirusTotal reports, from the local file information and from any other custom indicators that we may develop in the future. Our Python program also supports automatic data collection and logging from open source malware repositories. And we have a custom website for visualizing campaigns, so different malware campaigns, in order to track individual projects so that you can track multiple samples per a campaign and do your analysis, your comparisons on a campaign level instead of a per sample level.
So in the future, where we want to take this project is we want to be able to develop our visualizations of our custom indicator comparisons. So we want to be able to generate our own custom locality sensitive hash, and we want to be able to draw meaningful comparisons between malware samples using that custom hash. We also want to be able to mathematically verify that our locality sensitive hashes are telling us information that's actually true. Just basically by going through the algorithms they use and verifying that the way they're storing data and the way they're encrypting and generating the hash is mathematically sound. We also want to be able to automate gathering data from VirusTotal and transforming that or translating that into structured threat intelligence expression language, or STIX. We also want to be able to search different samples by libraries or functions or dependencies, or basically develop tags and assign them to these samples so that we can search we'll search a little more efficiently. And we also want to be able to easily deploy our program so that lots of other people can use it and gather intelligence on the increasing number of malware samples. So that's the malware analysis at scale with Elasticsearch project. And now we'll open the floor to questions. Thank you.